Welcome to Math with Miss Swartz. Today we're going to take our information on equations and multi-step equations and continue to add little pieces to it. Today we're looking at combining like terms in solving equations. So what we're going to be thinking about is when we're looking at an equation, there may be times when one of the sides is not as simplified as possible, and we can simplify it further, which would help us get our variable alone. So we have to kind of understand a few things before we can jump into actually solving equations that have like terms involved. First thing, we have to know what like terms are. So like terms are terms of an algebraic expression that have the same variables raised to the same exponent. So you'll notice 4 and 8 are considered like terms. Well, let's think about our definition. So terms of an algebraic expression that have the same variables. Well, these don't have variables. So to say they have the same variables is pretty true because neither of them have one. We would consider these constants, but they are like terms when we have constants. And they're also raised to the same exponent. Okay, these would be raised to an exponent of 1 because 4 to the first power is just 4. Okay. That comes a little bit more into play when we do have variables involved. So 2x and 7x would also be considered like terms because they have the same variable, x, and they're raised to the same power. So in this case, x is raised to the first power as well. Where you would see powers come into play, we won't deal with it too much, but something like this could not be combined with this. Okay, because they have different exponents, these are not like terms, so we can't add those together. But something like 4 and 8, if we were adding them, we could consider those to be 12 combining like terms. If we were adding 2x and 7x, well, if I have 2x's and I have 7x's, oops, 1, 2, 3, 4, 5, 6, 7. How many do we have total? If we were adding them, we would have 9 x's. So we could combine like terms in that fashion. You probably have seen problems that you've worked on before that look like this. Let's go 3y minus 2y. Okay? Because they have the same variable and they're raised to the same power, we can actually work with our constants and just subtract those. 3 minus 2 is 1, so 1y, which is also the same as y. So what we're going to be doing is taking this knowledge of like terms and simplifying parts of equations so that we're able to solve for our variable when we are looking to solve. So let's look at some examples that we have here. First, we're just going to start with expressions where we're just simplifying expressions. We're not solving our variables yet. We'll get to that point in a little bit. So here, 3z plus 5z. So they do have the same variable. They do have the same power or exponent, so we can just add our constants. 3 plus 5 is 8. Okay, let's look at this next one here. 2x minus 10x plus 5. So I have to determine which ones are like terms. Well, 2x and 10x are like terms because they both have an x and they are both raised to the first power in this case. 5 would not be considered a like term. That would be something that we would just have to leave alone for now. So 2x minus 10x, or 2x plus negative 10, different signs, so we subtract, we get 8, and we have more negatives. So we'd have negative 8x plus 5. So then we have to determine, can I simplify this any further? Well, if they're not like terms, that's as far as we can go. Okay, so look at this next one. We have 4z plus 8b plus 11z plus 9b. I have to find my like terms. So I have 4z. I'm looking for anything else that has a z. 11z has a z, and I'm adding all the way across. So 4 plus 11 is 15. So I have 15z. Now I can also look at these other ones. I have 8b. Does any other have b involved? So 9b as well, and I'm adding. So I'm going to add these. 8b plus 9b would be 17b. Now make a decision. Can I combine these? Are they like terms? Well, they don't have the same variable, so I can't, so that's as far as we can go. Last one we'll do together here. We have 18y plus 9 minus 13y minus 12. So what I like to do here is make sure that I change all my subtraction to addition and change the sign of the next number, just so I'm adding all the way across. So now look for like terms, 18y and negative 13y. So if I add those together, I have 5y, and it would be positive in this case because there's more positives. And then I have 9, and my constants are also like terms, so I can combine those. 9 plus negative 12 would be plus a negative 3. Can I combine 5y and 3? No, because they do not have the same pieces there. Variables. Alright, so I want you to go ahead and try, I know these are in the way right now, try 12x minus 3 minus 7y. See if there is anything you can do there. Hint, there may not be. And then go ahead and try 49 minus 16h plus 14h plus h. See what you can do there. Okay? So this is just combining the like terms. So how does this apply to our equations unit? So let's try when we're going to have to combine some like terms with equations. So here we go. We have 7x minus 3x equals 16. So on this side, if we're trying to get x alone, I have two x's here. What I can do is simplify this side of the equation by saying, okay, I have like terms, I can subtract these. 7x minus 3x is 4x. So now I have an equation that I can solve. I'm going to divide by 4, so x will equal 4. Okay? I could check that by plugging it in. 28 minus 12 is 16. So this one, I'm going to combine any like terms I have to simplify. So I might go through and change subtraction to addition and change the sign of the next number. So here, 3y plus negative 5y, I'd have negative 2y if I add my coefficients, plus negative 11 equals 11. So now I can just solve it like a two-step equation. I'm going to add 11 to both sides. Negative 2y equals 22, 11 plus 11, and then divide by negative 22. So y is equal to negative 11. So for this problem, I had to simplify the left side here first by adding 3y and negative 5y, and then I was able to solve like we've learned how to do with two-step equations. Okay, so let's do the same thing here. We have negative 2c minus 12c plus 5 minus 6. So I might go through and change all my subtraction to addition. Okay, so now I have 2c plus negative 12c. Those are like terms, so I can combine them. If I add them, I get negative 10c because I'm subtracting with different signs. Then I have 5 plus negative 6. Those are also like terms, they're constants, so I'm going to do 5 plus negative 1. 5 plus negative 6 is negative 1. From there, now I have a two-step equation. I got to get c by itself, so I'm going to add 1 first. I have negative 10c equals negative 20, because I subtracted here different signs. Finally, I'll divide by negative 10, so c is equal to 2. And I could always check that by plugging it back in. I would have 4 plus negative 24 plus 5 plus negative 6. I would get negative 21. Once you have those down, I want you to try 3 and 4 on page 10 in your journal. Those are kind of your quote-unquote homework problems. Your homework today, because of the activity, is to finish this video and do these problems. Besides that, that's all you have. So have a great day, and we will catch you next time.